morning. In the last class we have learned about the total angular momentum, how the different orbital angular momentum and the spin angular momentum combine together to form the total angular momentum J. There are different possibilities that the L and S can be, the resultant L and the resultant S can be combined to form the J value, and there are different possibilities for the J values, that is L plus S to L minus S. So we will get different values for the total angular momentum. And also we have seen that why anomalous Zeeman effect occurs. And today we can go into the some notations that are used for representing a particular state. That is known as the term symbols. The different notations and different values or numbers or letters that represents a particular state is known as the term symbols. The orbital angular momentum is represented by small l, and when l equal to 0 you have when l equal to 0 you have s orbital, l equal to 1 you have small p orbital, etc. l equal to 2 you have d orbital, etc. And like this, here for the resultant orbital angular momentum capital L, we also have a specific notations for this resultant orbital angular momentum. So for the total orbital angular momentum quantum number L, this is the resultant or total orbital angular momentum quantum number. That is when L equal to 0, we can represent the state as capital S. When L equal to 1, we can represent it by capital P. When L equal to 2, we can represent it by capital D, etc. SPDF, in the capital letter notations, we are assigning the resultant or the total orbital angular momentum of a particular state. This is the representation of the resultant or total angular momentum of an entire electronic state. So, we are usually representing 1s to something like a small s 1s state or s square 1s2, 2s2 something. This is the small n, this is the angular momentum, this is the number of electrons, this is the individual representation of a particular state, and this is the total angular momentum, orbital angular momentum state. We have here also some representation. That is, usually we are representing the total angular momentum or a particular electronic state, the entire electronic state, using some notations. Example, this is usually this is one of the state 2p sum 3 by 2. This represents an electronic state. What are the different terms used here? The 2 here gives the different ways in which the L and S, or it is the possible ways in which the total angular momentum vector L and the total spin angular momentum capital S is combined. That means this is the total or different possible ways in which J is combined. That means this is the number of different possible values for J. So L and S combine together to form the J vector. So if this 2 represents the different ways in which L and S combines, that means this is the possible values, or this represents the possible values for J. And in that J, in one J, suppose that here it is 2 possible ways. This is the 2 possible ways. So 2 possible ways means you have J, there is 2 J values will be there. For each J value, that will be oriented in space in accordance with the MJ values. That you have already, yesterday we have derived that for a particular J value, the orientation will be there will be 2j plus 1 different orientations, that is from minus j etc. up to plus j values will be the orientations will be be there. That is the mj values. Yeah. For each j value, you have different orientations. So this 2 is actually known as it is the number of possible values for j. This is actually known as multiplicity. This value is the 2 here represents the multiplicity of the particular state. And this multiplicity equal to 2s plus 1 if L is greater than S. 2s plus 1 if L is greater than S. And the j will take values from L plus S to L minus S. Since L is greater, so L plus S to L minus S values, these are positive values you will get. L plus S to L minus S, the value for j. This is the number of possible values for j, that is, this is for the multiplicity, that there will be 2s plus 1 different values for j. So, the j will take values from L plus S to L minus S. These are all vectors, L plus S values, these are all vectors for j value, these are all vectors. So, j vector you can represent it by L plus S to L minus S. That means when S is equal to 0, S is equal to 0, that is 2s plus 1, that is there will be only one state. When S is equal to 0, only one possible value for j, that is a singlet, that is known as a singlet state. That is here a singlet state. That means when S is equal to 0, j is equal to L plus S to L minus S. Then if S is equal to 0, only one possible state will be there. Possible values for j, that value will be whatever the value for L. That means for j, L plus S and L minus S to L minus S is the value. When S is equal to 0, you will have j is equal to S. J is equal to L. That means here when S is equal to 0, only one value for this j, that is j is equal to L. Whatever the value for j, then you will have L, then you will have that value for j. When S is equal to half, the multiplicity will be, here the multiplicity is 1, multiplicity 1. For S is equal to half means the multiplicity is 2. That is, this is a doublet state. That means j is equal to L plus or minus half. Then how we are getting the values? J is equal to how to L minus, the next one will be L minus half comma L minus half plus 1. This itself will be L plus half. So only two values L minus S and L minus half and L plus half, that is j will take values from L plus or minus S. This is the doublet state. There are two values for j, that is L plus half and L minus half. When S is equal to 1, that means there will be multiplicity of 3. 2s plus 1 will be the multiplicity, that is multiplicity is 3, you will get the 3. So you will have, what is the value for, that means this is a triplet state. This is a triplet state. Then what is the value for j? J will take values from L plus S to L minus S. That means that is equal to L plus S to L minus S. That means we can start from here L minus 1, here 1, L minus 1 plus 1, then L minus 1 plus 2, etc. That means L minus 1, this is L, then this is L plus 1. That means only three values, that is here for 1, L is equal to 1, so L plus S to L minus S, that is, there are 3 possible values, that is, 3 is the multiplicity, so there are 3 possible values for J, that is L minus 1, L and L plus 1. Like that, we will get the different possible values for J. If L is less than S, you will have the multiplicity 2L plus 1. If L is greater than S, you will have L is less than S, you will have multiplicity 2L plus 1. Usual notation is 2S plus 1. The multiplicity usually represented by 2S plus 1. So this is the multiplicity. This represents the total. This represents the total orbital angular momentum quantum number. That is, this is the P state. That means when L equal to 1, you will have this state. When L equal to 1, you will have this P state. So it represents the total angular momentum quantum number. This 3 by 2 represent, here the 3 by 2 in this notation represent the J value. So we have large number of J values in accordance with the spin. This particular state this particular state can have 2 J values, and this particular state is for the J 3 by 2 value. So 2 P 3 by 2 means this is the P. You can see that how it will come. That is, here 2 is the multiplicity. That is 2S plus 1 equal to 2. That means S is equal to 1 by 2. S equal to 1 by 2 means there will be 2 states. J will have L minus S and L plus S will be there. So what is the value of L here? This is the value for L is equal to 1. So the possible values for J is equal to L plus or minus half means representing L is 1 plus or minus half. That means J can take values 1 plus half, that is 3 by 2, and 1 minus half, that is 1 by 2. So this particular state, this J value is represented by this one. This is the total. There are 2 possible states for this possible values for J. This is the 3 by 2 value. So what is the orientation for? What is the different orientations for this L equal to 3 by 2 value? L equal to 3 by 2 value will have MJ orientations. That means minus J to minus J plus 1 etc. up to plus J. That is, minus J means minus 3 by 2. Minus 3 by 2 plus 1 means minus 1 by 2. Then minus 3 by 2 plus 2. That is 1 by 2. Then minus 3 by 2 plus 3. That is 3 by 2. That is the plus J. So these are the this thing we have already done in the last class. These are the 4 orientations for this particular J value. That is, the J will take different orientations. That is, 2J plus 1 different orientations will be there for this J. That is, what is the different orientations for this? When J equal to 3 by 2 means 2 into 3 by 2 plus 1, that is 4. That is equal to 4. That is 2, 3 plus 1. So 4 different orientations for J. That is, the orientations are this one. So only for J equal to 3 by 2 you will have different orientations for a particular value of J. So for J equal to half you will have MJ values minus half to plus half. So you can see that the orientations will be 2 into 1 by 2. That means 1 by 2 plus 1, that means 2 possible orientations for J equal to half. This thing we have already done in the last class. So this is the representation of a particular electronic state in the LS coupling scheme. So you can have, this is the multiplicity, this is the J value and this is the L value. So you can write in general the 2S plus 1 LJ. This is the usual notation for a particular electronic state in the LS coupling scheme. These descriptions are known as term symbols. This is a term symbol. So general term symbol is like this. This is the multiplicity. This is the L value. usual notation for this multiplicity values. Or these notations are, or these descriptions are known as term symbols. The term symbol for the ground state of sodium is given by 3, 2s half, and that of the first excited state is given by 3, 2, 3, 3 pi. This representation is can be read as doublet P 3 half. This is doublet S half. Like that we are reading we can read this term symbol. Doublet P half, doublet P 3 half, doublet S 1 half. Like that we can read. Usually we have added some number here. This is actually representing the n, the principal quantum number. It is representing this 3 represents the n values. So this is the term symbol. Again, in some notations, in some books, you can see that we can also represent the particular state, particular principal quantum number. Also, we can add 3 to s by 2, something like that. So we have to find the possible quantum numbers. We have to find the possible quantum numbers n, small l, j, etc. values for this particular state. So we can take the first value, that is the 3s2 s by 2 s half. This means n equal to 3 here. What is the multiplicity here? What is this value? This is L. This is S. So we can have L is equal to 0 here. 2s plus 1 is equal to 2. Means S is equal to half. In this case, you can see that. So you can see that for this particular level, this 2s plus 1 is 2 and S is equal to half. And in the place of total angular momentum, you have the S orbital here. S value is here. That means L equal to 0 for S. Here spin value is half, since 2S plus 1 is 2. Then you have this S is equal to half. And you can see that here L is less than S. So since L is equal to less than S, the multiplicity is given by 2L plus 1. So you can see that since L equal to 0, 2L plus 1 gives 1. That means the multiplicity is represented by the number of values for J. That means J will have only one value in this case. And our usual term symbol representation that we have already discussed is that n 2s plus 1 lj. That is, this is the principal quantum number. This is always 2s plus 1. We have to assign this value for 2s plus 1 always. And this is the j value. Here in this case, n is equal to 3. Then 2s plus 1 is given by 2. And L represent, L is given by the S value, that is L equal to 0. That is the S1. Then J is equal to 1 by 2. So the usual symbol is like this. So, but we have to calculate the multiplicity from the S and L values. That in this case, 2S plus 1 equal to 2. So S is equal to half. And since this is S, capital S, we have L equal to 0. So since L is less than S, you have only 2L plus 1 values for the J. That is only one value. That is half value. That is, here for J is equal to, J will take the different values, L minus S to modulus L minus S to L plus S. That is, here only we will get half. Then what is the J value? J is equal to you can take the small one. J is equal to half. Then Mj will take values plus or minus J or minus J, etc. up to plus J. That is minus 1 by 2. Minus 1 by 2 plus means plus half. That is the plus J itself. So only you have half. J equal to half here. So usually this J will take values from L minus S to L plus S. So L minus S here means what is L? That is 0 minus, yes, this is actually modulus you can write. You can write here small n, we can represent here. For single electron you can represent like this. So 0 minus half to 0 plus half. So these are the possible values for J. That means only we will have half. Only J is half value. Then for the next one, that is 3p2 3 by 2. Here n equal to 3. 2s plus 1 is equal to 2. That is s is equal to again 1 by 2. Then what is the value for J here in this particular notation? J is equal to 3 by 2 here. Then in this case Mj will take values from J minus J minus 3 by 2. Minus 3 by 2 plus 1 means minus 1 by 2. Then minus 3 by 2 plus 2 means 1 by 2. Then 3 by 2. These are the four orientations for the J, particularly this one. Here you can see only J will take only one value here in this case. But you can see that here the J value is usually from L minus S to L plus S. That means L minus S means what is the value of L here? You can see that here L is equal to, this is P, so L is equal to 1. So L minus S means what is 1 minus 1 by 2 to 1 plus 1 by 2. L minus S and L plus S, there are two values, L minus S to L plus S. To L minus S to L plus S, that means here 1 minus 1 by 2 means 1 by 2, then 1 minus 1 by 2 plus 1 plus half, that is 3 by 2. That is here also L plus S means again you will get up to L plus S means 1 plus half, that is again 3 by 2. So only two possibilities will be there. The maximum values is up to L plus S. So L plus S is also given by 3 by 2. So only two values will be there. L minus S to L plus S means L minus S, then L minus S plus 1, etc. up to L plus S. So L minus, the second term itself is the L plus half term, that is 1 plus half term. So two values for J. J will take two values. If this is the one state here, one particular state here. So in this J value, if the J value is this one and the L and S values are this one, there may have two possible values for J. That is J is equal to 3 by 2 already we can have here. So if for J equal to half, J equal to half, you will have Mj values minus half to plus half. Two J values will be there for J equal to half. The remainings are same. N equal to 3, S is equal to half, J equal to half, and J equal to plus half and minus half and plus half. So this is the particular, for this particular state you have these values. But when this for this J value or for this L and S value, this L and S value we can have another state, that is the J equal to 1 by 2 state. For that state you can have these are the J value and this is the possible orientations for this J. That is 2J plus 1 possible orientations will be there, that is equal to 2 into 1 by 2 plus 1, that is equal to 2 possible orientations will be there for this J value. Next question is check whether 2 doublet P 5 by 2 state is possible or not. That is, check whether 2 doublet P 5 by 2 state is possible or not. So you can see that in this case n equal to 2, 2s plus 1 is that is s is equal to half. Then p, this is the p state, that means l equal to 1. Then j is equal to 5 by 2 here in this case. So from the L and S values, what are the different possible values for j? That is L plus L minus S to L plus S. Then what is L minus S? L minus S means L equal to 1, 1 minus 1 by 2 to 1 plus 1 by 2. This is the maximum value. Then what is 1 plus 1 by 2 is 3 by 2. 1 minus 1 by 2 is 1 by 2. The next value will be 1 minus 1 by 2 plus 1. That is 1 minus 1 by 2 plus 1 will give, what is 1 minus 1 by 2? 2 minus 1 by 2, that is 4 minus 1 by 2, that means 3 by 2 itself. So only two values will be there, that is 1 by 2 and 3 by 2. So the maximum value is 3 by 2. So you never have 5 by 2 state, 5 by 2 value for j in this particular case. So this particular 2 doublet p 5 by 2 state is impossible. Only maximum value for j in this condition or in this coupling will be 3 by 2. So 5 by 2 state, 5 by 2 value for j is impossible. That are all about the LS coupling. The JJ coupling, only what is JJ coupling, that we have already told in, that I have already told in the last class. So you have to go into detail and do the problems for this LS coupling. So now we can stop. The next thing is the last session of this chapter, that is the X-ray spectra, that we can take in the next class. Now we can stop. Thank you.